Ever wondered how machines learn from data that's constantly changing? Imagine a system that adapts in real time to detect fraud, predict equipment failures, or personalize your streaming recommendations as your preferences shift. That's the power of online learning, a cutting-edge approach to machine learning designed for streaming data and concept drift. But here's the challenge. Traditional tools like scikit-learn were built for static datasets, not the fast-paced, ever-evolving world of real-time data. Platforms like MOA or scikit-multiflow tried to fill the gap, but they often struggled with outdated algorithms, complex codebases, or limited Python support. Enter AwesomeOL, a groundbreaking Python toolkit from Tsinghua University that's redefining how researchers tackle dynamic data. So what makes AwesomeOL stand out? Let's dive into its core strengths. First, it's extensible. Researchers can plug in custom models or experiment with state-of-the-art methods for handling concept drift, those sneaky shifts in data patterns that can break older systems. Whether you're dealing with noisy labels, semi-supervised scenarios, or dynamic queries, AwesomeOL provides the flexibility to innovate. Second, it's user-friendly. The team wrapped everything in Jupyter Notebooks, so you don't need to wrestle with complex code. Select your parameters, choose your algorithm, and let the toolkit handle the heavy lifting. Plus, pre-built demos get you up and running in seconds. And here's the cherry on top, visualization. Online learning can be hard to debug, but AwesomeOL lets you track model performance in real time. Watch how your algorithm adapts as data flows in, turning abstract concepts into actionable insights. But how does it all work under the hood? Let's take a quick peek. The toolkit's architecture revolves around classifiers that learn and predict in real time. Think of it as a two-step process. First, the model fits to initial data, then it continuously updates as new information arrives. Techniques like online gradient descent ensure the model stays sharp, adjusting weights incrementally instead of retraining from scratch. The workflow is streamlined. You pick your parameters, select your model, and let the system handle the rest. From data streaming to evaluation, visualizations make complex patterns easy to understand, turning raw data into clear, actionable results. The team behind AwesomeOL didn't just build a tool. They created a bridge between cutting-edge research and practical application. With support for the latest algorithms, a clear structure, and a focus on collaboration, this toolkit is a game-changer for anyone working with dynamic data. But online learning isn't just about adaptability. It's also about tackling real-world challenges like unbalanced data. Imagine trying to spot rare fraud cases in a sea of normal transactions. Traditional models struggle, but adaptive systems are changing the game. These systems act like adaptive chefs, tasting the dish as they cook and adjusting ingredients on the fly. Techniques like dynamic submodular learning prioritize the most critical data points, while adaptive chunk-based methods break data into manageable pieces, rethinking strategies as each chunk arrives. The results? Faster change detection, reduced errors, and robust performance on imbalanced datasets. In industrial settings, these systems improve fault detection in machinery, preventing breakdowns before they happen. In healthcare, they help diagnose evolving conditions, like tracking the progression of a disease over time. Tools like River and scikit-learn are making this tech accessible to developers, while frameworks like Mecha extend these ideas to complex, multi-label problems. It's like giving machines a built-in sixth sense for change. So next time you see a self-driving car or a smart assistant, remember, behind the scenes, algorithms are constantly learning, adapting, and staying one step ahead of the unknown. The future isn't static, and neither are the systems that power it.